Today we're going to talk about how to find slope, and we're going to do it without using a calculator. It's faster, it's easier, there's no reason to do anything with the calculator to find slope. We're going to focus on three ways. The first way, from a graph, we're going to learn how to count it. The second way, from a table or set of ordered pairs, we're going to calculate it. And the third way, we're going to learn how to look at an equation and find slope. So let's start by talking about the different types of slope. You should know most of these, but we're just going to hit them real quick. A positive slope meaning going up to the right. Remember, we're always going to read left to right. A negative slope going down to the right. Again, going left to right. A zero slope, which we normally look at like a flat line, meaning it's going up zero and over or some. And undefined. Not no slope, but undefined slope. That's because when we find that slope, when we calculate it, we're going to be dividing by zero. And as you'll learn in every math class, you can never divide by zero. So that brings us to our first category, finding slope from a graph. And that's the easiest way to do it. You're given the points. You find any 2 points. That's the great thing about slope. It's going to be the same. It's a rate. So it's going to be the same no matter what point you pick. So you just pick any 2 points on that line, like those two, and you count. And remember, slope is rise over run. Well, rise over run means up and down over left and right. So if I pick these 2 points, to go from the bottom one, I'd go up 3 and over 2. That would give me a slope of 3 over 2. And it's going the positive direction, so it's positive 3 over 2. Now remember, I can pick any 2 points on here I want. So let's choose this one, and let's choose the one way up here. Okay, so now up 1, 2, 3, 4, 5, 6 over 4. 6 over 4 is my slope, but remember, slope is a ratio. That reduces to 3 over 2. So no matter what 2 points you pick, you'll always get the same slope. But you just pick 2 points and you calculate rise over run. For the second one, we'll do the same thing. We just pick a couple points, like say that one, or maybe that one. Here's another one. And again, this one is going up to the left, so we know that this slope is going to be a negative number, whichever slope it turns out to be. We just count. Starting from this one, we go up 2 and over 1, 2, 3, 4, 5, 6, 7, 8. So it's up 2 over 8. And again, it's a ratio, so we reduce it, negative 1/4. Again, we can pick anything, maybe this one and this one, up 1 over 4. So again, negative 1/4. Now, I'm not a big believer in having to work with negative numbers, so in this case, I look at it and immediately I notice this goes up to the left. Therefore, whatever answer I get, the slope has to be negative. We don't have to worry about calculating with negatives at all. And these last two are examples of the 2 other types of slopes that are a little bit different. So we'll start with this one, this purple one. And we'll look at, say, any 2 points, those 2 points. Notice they do not go up at all, so the rise is 0. In this case, they go over 3. 0 divided by 3 is 0. And again, pick any 2 points you want, here and here. It's going up 0 and over 10. 0 over 10 is 0. So a horizontal line like this has a slope of 0. Now the vertical line, again, pick 2 points. In this case, it's going up 3, but it's going over 0. And if you calculate 3 divided by 0, you will get an error. That is why this one is called undefined. Because no matter how you try to calculate it, you cannot do it. You cannot divide something by 0. Ask me in class and I'll demonstrate it, but you can't divide anything by 0. It's a given fact. The second way we calculate slope is by using the actual slope formula. Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. I will probably need to explain this a little more in class, but the 2 and the 1 come from the ordered pairs. We're dealing with two ordered pairs, so therefore we have to number them differently. Now understand, when you plug in information, you can go in any order as long as you go in the same order. So that's the key there. So let's try this example. We have two ordered pairs, 11, 4, and 8, -2, and we want to determine the slope. Now, one way to do it is to actually get a piece of graph paper and graph those 2 points, but we don't have one of those nearby. So we're going to follow the formula. And as I said a moment ago, it doesn't matter which one of these you choose to be the first one and the second one, as long as you choose one. So let's choose this to be the first and this to be the second, which makes this x sub 1 and this y sub 1 and this x sub 2 and this y sub 2. And we're just going to plug into the formula. -2 minus 4 divided by 8 minus 11. And then we can calculate -2 plus a -4 is -6. 8 minus 11 is -3. And -6 divided by -3 is +2. So the slope of these 2 points is 2. It means it's going up to the right at a slope of 2. Easy to calculate. Now let's look at a table. In doing a table, it's like picking 2 points. You can choose any 2 points and use the formula, or you can do this. Let's say I'm taking those 2 points. I notice that to go from -15 to 10, I'm going up 25. And to go from -3 to 2, I'm going up 5. Well, if we remember, rise over run, which is also the change in y over the change in x. So in this case, there are the y's are going up 25, the x's are going up 5. 25 divided by 5 is 5, and that's a +5. We can check, again, anywhere on here we want. 15 to 25 is 10, 3 to 5 is 2, 10 divided by 2 is 5. We can check it anywhere we want. Okay, -15 to 40 is 55. -3 to 8 is 11. 55 divided by 11 is 5. Our second example, we can pick any 2 points. We're going from 6 to 0. That means we're going down 6. Be careful with the direction here. 0 to -3, we're going down 3. So we try the ones on the left side, the x's. -8 to 4 is going up 4. -4 to -2 is going up 2. So if we compare the equivalent ones here, for the top 2, it's -6 over 4, which is -3 over 2. That appears to be the slope. And we can see for the second grouping, it is the same, -3 over 2. So we can be assured that the slope of this second table is -3 over 2. And finally, that brings us to finding slope from an equation, which is one of the more useful things to do. Can be easy, can be difficult. We'll start off by looking at the general form of a linear equation, which is y equals mx plus b. And as you've seen me write earlier, m represents the slope. So the easiest way to find slope is to have an equation in this form, like y equals 5x plus 9, and just take a look at it. The slope of this line is 5. We know by looking at that, 5 is positive. That means the line is going to go this way. It's going to go up 5 over 1. So we have a lot we can gather from that piece of information. Now remember, slope is the coefficient of x. It's not the x. If you write this, we will count that wrong. Okay, the slope is the coefficient. It's a number, not the x. Now, but that was easy. We can get the slope from any equation as long as it's in this form. This equation, not in that form, but we can make it that way. We can get, all we have to do is try to solve for the y, which we started doing with literal equations. So if we look at the y is being multiplied by 2 and it's being added to 3x. So that's what we're going to have to undo. So we'll start by subtracting 3x, which we know we cannot combine there. So that's going to give us -3x plus 6. Now if you wrote 6 minus 3x, that'd be absolutely fine, but I'm trying to keep it in that order just to make things a little bit easier for us. But we still have to get rid of the 2, so we're going to divide that. Remember I showed you can do it by each and every piece of it. So when you do that, you end up with y equals -3/2 x plus 3, because 6 divided by 2 is 3. Now, the important thing there is we now have it in this form, so we can tell that the coefficient of x which is the slope is -3/2. So we found the slope by looking at the equation. Even though it wasn't in the form originally, we solved it, which is one of the major reasons why we learned how to do literal equations. Now, you've seen all the ways that we can find slope. Go back if you haven't already done so and try out the practice samples, and we will check them first thing when you get to class, as well as answer any questions that you